Niet. Jawel. Here we go. Enjoy, Jellis.
So for the record, you can take pictures as long as you tag us in the tweets. So hello everybody. My name is Yillis. This is Joseph. We have two more J's, Jelle and Jurre, doing other talks. And our talk today will be about doing open source wardriving with ESP32 for the absolute beginners. We just added that for you. So I was an absolute beginner once. So I don't know if you recall GHP back in the days, 89, Paradiso. So that was my first MCH. I was caught on the computable, like on the front page. And at that time we were doing like freaking, doing stuff. I actually admitted it in front of the National Police, but it was verjaard. So they don't no longer find me for that. I'm from the days that we had these kind of devices, like the acoustic modems. So when I was like dialing into networks, connecting to the internet, doing FidoNet to colon 512/9, it's me. My wife came home after work and saying, "Hello, darling," and it was like no carrier, and then we could like start all over. At that time, actually, my wife worked for the phone bill. We had a phone bill of 1,700 guilders at that time, so it's like ancient currency, and I really liked that. So one of my first thing that I did for my internship at an architect agency, I found a modem, like a video tel modem, which was 1200/75, like a really odd baud rate. And they didn't know what to do with it. And I had those lists of telephone numbers that you could dial to see if there was like any carrier, and like we found KLM at that time and some other stuff. So we were like creating a script to kick off commands like ATDT phone number and see what happens. And at that time we had some pizza and had some fun. I actually did not do anything dangerous at the time, but was a lot of fun, and that sparkled my interest of like collecting stuff or like dialing into stuff. And yeah, actually the screenshot was the war games. It was the war games screenshot where he dialed into the Pentagon at the time. Yeah. So I have a impulse control disorder. So I tend to buy stuff. So if you follow me on Twitter, yillis_com, you will likely see /mail, me sharing some things that you didn't know you really, really want to buy today. And I run into a thing called a 2.4 dish antenna of the TNO, which is like a research institute. And they use it like for some kind of research. And thought, well, if I take like one of those links is dongles, like 2.4 gigahertz, I can connect this like a really huge device to it, and then I can scan like whatever device you have. And at that time there was like OBEX FTP, where you could authenticated connect to a phone, download like the entire contact list, see all the data. So a lot of fun. Hack 5 creates some awesome stuff. So this is the Wi-Fi Pineapple. It's a Mark 4, Mark 5. And yeah, you can like alter those things. So there's like GPIO header, so you can add new functionality to it, but also like increase the antennas and add like another thing. And I like to fiddle with electronics. And wow. Wow, who did this? So this is actually a Wi-Fi pineapple detector. So when someone is like sending de-authentication messages around, it will actually light up. So it has like an 8266 microcontroller with a MOSFET that is addressing this thing. So I bought this at Aldi for €5. So the entire, thank you. So for the people that are dialing into the screen and not seeing what we are doing, there's a light with a Wi-Fi pineapple, or no, a pineapple that lights up whenever someone sends the authentication messages. So there's a lot of people actually working on ward driving, scanning stuff. And one of my favorites was Kevin Rose hosting a show called The Broken. So you had The Broken 1, 2, and 3, and also System. And this was one of the episodes where they created a video war driver. So where they were driving around. So what they did is like they bought a device that is able to transmit a signal over a wireless frequency. So if you take away the camera part or like the broadcasting part and only take the receiving part, you can just wander around the street and just collect whatever information that you find, and you will see the actual images. So what they created was like a box with a receiver and a electronic circuit switching one of the 4 channels every time. So there's like a lever that allows you to see how quickly it went. They use like the antenna, like a built antenna made out of a tin can. But they also had like these ones just to find. So this one is an omnidirectional, meaning that you will collect all the data around you. And the other one is like a directional if you actually know where the antenna is. So there's these devices. This is like an old screenshot of Kismet. So Kismet is a piece of software that allows you to collect data on all kind of information. So it's Zigbee, it's Bluetooth, it's BLE, it's Wi-Fi. I think they support Geiger counters as well. So there's like 433, 868. So collects a lot of information if you want to like see what kind of information that you have around. So usually you use like devices as a Raspberry Pi or a NUC. Sorry, I'm in the way. And that makes it like really flexible because you can like address everything. But there's one thing. I don't know if you're familiar with these 2 devices. So one on the left has a microprocessor, meaning you are able to run software on a like an operating system that's very flexible. And the one on the right is an Arduino, and that's a microcontroller. And a microcontroller allows you to do limited stuff, but it's like more stable. So if you pull the power, there's not an issue. Like if you pull the power on the Raspberry Pi and you do that like 5 times, then you probably corrupt the SD card and you will no longer be able to work. So if you are in an unstable environment with batteries or with a car engine or whatever, the one on the left is harder to do. So I ran into Joseph. Joseph is the boyfriend of one of my twin sons, Jelle, and he allowed me to beta test his device. So was this device, looked really, really cool, and it worked with microcontrollers, so allowing it to just unplug it and replug it and it would immediately work again. Was like really, really tiny, was like really power friendly. So I really wanted to go around and do an effort of losing some weight. Did not quite happen, but at least I had the motivation to do so. So actually one of my other twin sons, Jure, I host a lot of talks with him. So we travel around the country, even abroad, to do talks together. So it is safe to say that I spend more in a hotel room with Jure than actually with my wife. So she's not here right now. She's not into hacking, camping, that kind of stuff. So I thought I should make this up to you. So what I did is I said, honey, we're going to do a road trip. What I meant was I have a war driver and I want to make as much kilometers as possible. But we went like from hotel to hotel. So we slept in wine barrels. We slept in hotel rooms with showers, like in the middle of the room. Slept in, yeah, like all kind of special places to make it really an adventure. But all the time, I had the war driver on my front. And even when we went out for sailing, I put it on the boat. I actually had two war drivers to be redundant. Yeah, I'm a system administrator after all. So this is a part of the chart that you will see of the Netherlands. And we spent 10 days traveling throughout the Netherlands to yeah, go out and reach whatever we got. And there was like so much information. And when I did that, uh, we have some dispute about it. I like to think I was like number 2 for that month. So, but I was like ranked really, really high as I was like committing all the data at the same time. So yeah, it was really fun doing so. I'm on Twitter, and what I like about Twitter is that I see a lot of projects going on, a lot of cool people doing these kind of things. So you have the Ponagotchi, which is like a device that captures EOPOL messages. It's more like an offensive tool, while this is like passive. So that's the Ponagotchi. There's El Contaro and Dark Matter with Force on Twitter hosting the Wireless Shit Show. So if you want to know more about those things, please follow those people to have more information. And I'm going to hand over the mic to Joseph, and he will explain more in detail what this epic, cool, magical device is that I got to borrow to test drive.
Thank you. I'll also take that.
Yeah.
Thank you. So, the war driver that I made is based on the ESP32, which is, as Yillis said, a microcontroller, rather than like a microprocessor which can run a full operating system. So that means that all of the software it runs is entirely coded by me, rather than like Linux plus Kismet plus the Linux kernel and all that overhead. But it wasn't always built on the ESP32. It started off as an Arduino Pro Mini, which only has, I think, 8 kilobytes of RAM, maybe even less than 8 kilobytes of RAM. So it's like very difficult to make it do much of anything. So in order to get Wi-Fi, this had an ESP8266 microcontroller, which can do Wi-Fi, specifically Wi-Fi scanning. So this particular iteration of the hardware was very basic. It didn't really work very well, but it did prove that a microcontroller rather than a microprocessor was indeed capable for war driving. So at that point, I moved on to a design that used two ESP8266 microcontrollers. And the reason why I switched to that is because you suddenly gain about 600 kilobytes of memory, which is like a huge performance boost. It allows you to implement so much more at once. And it was, again, quite a simple device, and it was all hand soldered, and you can see all the wires on the image on the right. It's like a complete mess of wires. So very hard to build yourself, and not a very good device, if I'm honest. So version 3, which is the current version, is, as I said, two ESP32s. But the main thing is it has a custom PCB, which means you no longer have to manually wire everything together. You kind of just slot everything into place if you're building your own. Of course, soldering it as well. So there's just a quick component list here. I won't read it all out because you'll probably get bored if I start listing all the specs. But the main thing is, again, the ESP32s. So the PCB that I designed looks like this. And all of the holes in the board are where you slot in the components. So I'm using full-sized ESP32 development boards rather than bare ESP32s. Sorry, I think I'm blocking the screen for someone there. So the reason why I'm using a full development board is because it includes many things that I would have to implement into the PCB myself anyway. So for example, it has a USB port, it has like a serial programmer, so you can just plug it into a computer and program it, which makes it significantly easier to work with. And this also has the ability to connect a custom external antenna of your choice, which means you can use one of those huge antennas that Yelis showed on one of the first slides, where you can like receive things from 5 kilometers away or sometimes more, or you can use like a tiny antenna. So I actually have one on the table here with small antennas on, so 20 centimeters in height, so that fits in my pocket, which is very convenient for walking, or if you're into biking, it's easy to attach to your bike, or of course on the dashboard of your car, or anything like that. So just quickly going over the specs, it's a GPS module, so it knows exactly where it is in the world, which is very important if you want to map this data. Micro SD card reader, it's simply so you can store the data onto more storage than what an ESP has. So you can put like a 32 gig card in, and that's enough for months of operation. Has a SIM 800L module. It allows the wardriver to pick up cellular towers for mapping as well. And it has a small LCD, just 0.9 inches. It's like a tiny screen, but it has the information you need, such as the number of networks in range. Temperature sensor, just so you know if it's like melting in the sun, which one of mine did once. And just a basic enclosure, which, yeah, not much to say about that really. So essentially it comes down to these components, and they're all cheap and plentiful on AliExpress or eBay or practically anywhere. And so it's, yeah, so two ESP32s talk to each other, and then like they're split into A and B, running two different pieces of software. And both ESP32s are dual core, which means this actually has 4 cores in total. And the reason why that's very useful for a device like this is because you can dedicate cores for nothing but scanning. Whereas if you had something like a Raspberry Pi or an Arduino, an Android phone, you would have the risk of not enough CPU power, because there would be overhead such as the operating system, maybe some kernel things happening as well. And essentially what could happen there is you would pick up less data because the resources are being used by other things. So having dedicated cores running nothing but my scanning code means you don't lose too much data, or any data at all, hopefully. So another image of what it looks like. So the bottom image is just 3 which I've assembled, and top left is the PCBs, and the top right 2 images are the assembled versions, one with an enclosure and one without. So next up is what you would actually do with this data and what exactly it is actually collecting. So that's where a website called Wiggle comes in, which Yelis briefly mentioned earlier. So Wiggle is a crowdsourced wireless geographical logging engine. It's compatible with Android. So if you have an Android phone, you can immediately start wardriving now just by downloading the app if you wanted to. Unfortunately, it doesn't support iPhone, and I am an iPhone user, which is why I built my own hardware instead of just installing the app. It's also compatible with open source software such as Kismet, which Yelis again mentioned earlier. So if you open up Wiggle, the homepage has a map which looks like this, and each dot represents a Wi-Fi network. So the kind of more orange to yellow colors are very high density Wi-Fi, whereas the blue is low density. So from this, you can see like the United States, specifically the East Coast, and also Europe, the United Kingdom, are very dense in Wi-Fi. But that's more to do with the fact that there's more people war driving them than the fact that they have more Wi-Fi. But if you were to zoom straight in on this map, straight in, this is right here. And this is a screenshot that I took about 1 week ago. So this shows the event from 5 years ago. So you can see like the SHA 2017 networks. You can also see any networks that people have temporarily set up. Like there's one with a slightly rude name and you know, just fun stuff that people have like hosted at these events, as I'm sure you're aware. So, oh yeah. So one called 1337 and yeah, stuff like that. So the war driver will collect data in a way that Wiggle natively understands. So you can run the device and then upload it straight to Wiggle if you wanted to. And the data just looks like this. So it's not human readable, but it is CSV, which means if you are into computer programming, or if you're into Excel, yeah, absolutely, then that means. No, no. So Excel or programming, you can. Sorry, is there a question? Shall I take the microphone over to you so we can all hear it?
So if it's just CSV, then it's also really easy to just create fake data, right?
It's very easy to fake data, yes. So while you can create fake data, realistically, you're not going to gain much by doing that. And you're only cheating yourself, really, in the long run. So I'm doing this more for the fun and the accuracy of the data, but some people will absolutely cheat it, yeah. And you do, if you zoom into like Antarctica or anywhere else that doesn't actually have people, you'll see like funny shapes in the map where people have drawn some kind of pattern that doesn't exist. So yeah, it happens and it's possible.
It's also point in time, right? It's also a point in time. So there's a scan now, but it can be like a scan like a week later or.
Yeah, absolutely. So you can like exclude certain time periods, or you can drill down into the data quite well. Yeah. So if you are into programming, you can kind of export this data because it's CSV. So you can implement your own kind of visualization tools or any kind of analysis you want to do yourself. So uploading data to Wiggle is quite simple. There's just like a basic upload form. And it will also show your previous uploads. So the screenshot at the very bottom is showing previous uploads and some statistics about them. So it'll tell you the number of networks you found, amount of Bluetooth, and so on. And a nice thing that Wiggle does is it will convert the file into Kml for you. And Kml is another open standard, which will which can be imported to something like Google Earth, which allows you again to visualize the data quite well. And there are also web-based tools such as this one, like I've forgotten the name of it, kmlviewer.nspot.net. So, for example, this is my journey entering the airport about 2 weeks ago, and then leaving the airport and driving around. Didn't show the whole journey for privacy reasons. So you can visualize the data quite well using open source tools or even your own tools. And Wiggle will also generate statistics globally. So for example, here they're showing they have over 907 million Wi-Fi access points in their database, which you can search for or look at on the map. And just generally useful stats or fun stats if you're into that kind of thing. So the types of encryption over time, so you can see how open networks have become less common and WAP2 has become more common. And we have a question at the back. I think you should have the microphone.
No, just wondering, like, if you had like a bunch of different, let's say, wireless endpoints inside a corporate compound or a military compound, and they're being monitored and whatnot. I mean, the device does need to send some sort of request to get some information out of the device. So I'm wondering, will it be possible to track people like that is trying to do that, or not easy to do?
Good question, and I anticipated that one, so it's actually in one of the next slides. So we'll get to that very shortly. So they also generate statistics for the individual users. So there's a leaderboard, which means if you are a competitive person, you can compete with other people who are collecting data and rise up through the leaderboard, if that's your kind of thing. So there are issues with war driving, but first I'll just start with why you would war drive. So, for example, for me, it's about the exercise. I always do it by walking, even though it's called war driving. I do it by walking. I did lose quite a lot of weight from it. Yeah, I was doing like 10-kilometer walks to collect as much data as I could. So that's one reason, and for me, it's the main reason. But another reason is you can collect cybersecurity data. So, for example, if you were doing some kind of penetration testing, it may be useful to know what brand of wireless access points a particular business is using. And with this kind of tool, you can find out. And because it's all open data, you can generally find out the information you need from other people who have been war driving, even if it's in like a different country or from months ago or anything like that. Also, it's a great project because you can build cool things. Specifically, if you're into electronics and programming and 3D printing and all that kind of thing, you can build like your own variant of the hardware. So this user that I found on Twitter, Lausanning, hopefully I'm pronouncing that right, but might not be, built a version of my war driver. However, because it's an open source project, they modified it slightly. So they added like a solar panel to the top. They added an integrated battery, and their intention was to leave it running 24/7, like on an overpass or something, to like collect all the cars going past. And yeah, so you can modify it how you like. So that's another great thing for me, the fact that you can kind of just tweak with it and modify it to your own requirements. And they also made this device. Well, it's the same device, but on like a really fancy bike. It's like a decoy, so everyone's too busy looking at the lights to realize that they're like collecting all their Wi-Fi data. So there is another user, Barry99705, who made a 3D printed case for the project, which looks like that. And again, with it being open source, you can kind of modify it to how you want it to be. But there are definitely issues to war driving. So, for example, like going back to the question earlier, it can be used for things like doxing, and in some cases it can actually be illegal to war drive if you're in some kind of really oppressive country, I guess, or if you try to do it in a military base or something like that. So in the way that it can be used to facilitate doxing, for example, is if you are somebody who names your Wi-Fi network after your own in-person name. So if I called mine Joseph Hewitt, which is my name, you could search for that on Wiggle and find my address.
Let's do so.
I don't call my Wi-Fi network that, so it is smart. So there are protections you should take. So, for example, you shouldn't put any personal information in your Wi-Fi name, because if you keep it generic, then no one's going to be able to search for you. And you should also use a randomized MAC address, which most phones do by default now. and we actually have another question. And I'm concerned. I'm concerned about like we need to like wrap it up in a few minutes, I think. So I should probably get to the end and then answer the questions at the end, if that's okay. So the next up is with the ESP32 being like a evolving, made by a company that's actively developing new devices. There is a new ESP32 which now does 5 gigahertz Wi-Fi, meaning future versions of the device will be able to search for both 2.4 and 5 gigahertz, which is very cool and something I hope to implement in the future.
Did you already talk about the 8266? The benefit of 8266?
Yeah,
Okay.
I think so. So yes, so going back to the PCB, for example, I am selling this on Tindy, and if you search for ESP32 projects on Tindy, it's quite high up. So this is ordered by popularity, and the one at the bottom right is my project, the PCB. So it's selling quite well, and people seem to really enjoy it, and it's nice to see people modifying it, coming up with 3D printed cases, and working on it in different ways. So I am going to go back to the question now. If you still want to ask it, I'll like give you the microphone so people can hear. If you still want to.
Does the no opt out, the phrase in your SSID, does it really work?
So there are ways to opt out of your data from going into Wiggle, and one of those ways is to append the string opt out to the end of the SSID. In theory, this should work. However, there are multiple websites which do wardriving. So we have Wiggle, which is the one I like because it's all open. But you also have the private ones owned by companies such as Google and Mozilla, and there's quite a few companies that do it. So there's a reasonably good chance that if you put opt out into your SSID, it will be ignored. And also, I think if you were to mark your SSID as opt out, people might be more interested in it.
Scan me.
Yeah, it's like people might look at that and think, okay, this is interesting. Why are they wanting to hide this? So I think the best protection from like being a victim of any of the issues of wardriving would be to blend in, to use like a generic Wi-Fi name.
Wi-Fi in the train. It's like a generic one.
Just keep it generic, yeah, and make sure you have good security, the latest encryption types for your network, good passwords, etc. Because ultimately, you don't really want your full name and address in your SSID with a weak password. It's asking for bad things to happen. So I am getting concerned about the time. I think we do need to wrap this up soon. I don't actually have a watch. Oh, okay. So, are there any more questions? Quite a few, actually. Who first? We need to like roll a dice or something. I'll like hand over the mic to.
Hey, so you did mention the GSM module briefly, but as far as I know, Weigel doesn't do GSM data. What do you actually do with the GSM related data, and what data are you collecting?
Okay, yeah. So the GSM module is collects only GSM, so not later protocols such as 4G, 5G, etc. Wiggle does collect this, meaning that it does get mapped. However, it's like kind of hidden beneath another menu because it is primarily like a Wi-Fi and Bluetooth website. So there is like an option you can choose that will show GSM data. But the other thing is, Wiggle, if you opt into this, will actually sell the data you've collected to commercial companies, and that can be used to improve geolocation databases. So, for example, it's very helpful for if you have a device which doesn't have GPS, it can use triangulation of the Wi-Fi and the GSM data to find its current position without GPS.
Or with GPS inside a building.
Or if you're inside a building, it can also be helpful to map your location inside. So yeah, GSM is collected and submitted to Wiggle. And in future, it may be possible to insert a SIM card into the device to upload data via the cellular network. Okay, so are there any more questions? Yeah, I mean, I figured you wouldn't all have the same question, but you never know.
So you have two ESP32s. How does the programming differ between the two?
So there are two ESP32s, and both of them are dual core. So that means one of them, so I should clarify, both of them are scanning continuously on one of their cores, whereas it's like a primary secondary situation. So the primary ESP does things such as handle the GPS data, put data onto the LCD, write data to the SD card, and yeah, I'll show the diagram actually. So they're both scanning simultaneously, and because there are two of them, it means you get double the antennas. Oh, yeah. So it's split up into A and B, which is just 1 and 2. So A is doing GPS, the LCD, and the SD card, whereas B is doing the SIM 800 and the temperature sensor, but they are both scanning at all times. And because you have two antennas one for each, it means you can firstly scan on two different channels at once, which practically doubles up what you can receive, and also means you can have two antennas at once, so you could have like a long range and short range, or any kind of combination that you wanted. So it just makes sure you collect a lot more data, essentially. But they perform a very similar role. Yeah. So there was a question over. Yeah, you moved. I was looking for you over there.
Did you ever think about reverse ward driving, where you just drop random access points somewhere and mess around a bit?
I set up my personal hotspot.
So what I had considered was like, you can use the ESP32 to generate an access point. So I was thinking of like going around generating randomly made SSIDs, hoping that other war drivers would find it, and then I would like maybe be able to figure out who was war driving and where. So I had considered it, yes, but I hadn't really thought of a good way to implement that. But also I'm more interested in like collecting the data, so that would like stop me collecting data in theory. But yeah, it's like a fun idea that maybe one day I'll do something with. And there was a question somewhere else, I think. Yeah, I thought there was.
The GSM, does it need a SIM card to work, or can you do it without a SIM card?
Yeah, so the SIM card isn't a requirement at all. And I wouldn't recommend putting a SIM card in there because I don't know what would happen. There's a chance you would get a bill if you did that. So no, it's not required and not recommended either. But in future, I will probably allow people to upload the data via the cellular network with a SIM card if they wanted to. But usually you would just use Wi-Fi to upload the data to the internet. But it would be cool to do it over the mobile network. So I think there was like more questions as well. Like, maybe not. I don't know. You wanted to say something, right?
Yes. So there was another project during COVID. My wife was watching a lot of vloggers and said, well, you do stuff with technology, maybe you and your nerd friends can hang out together and do fancy stuff. And one of the projects that we did was like inspired by Joseph's project, where we used an ecosystem called M5 Stack to connect devices together. And as these devices were really cheap at that time, just before the components all getting out of stock everywhere, we used like a little tiny M5 stack and a really tiny ESP32 and connected those all together to scan stuff. So this actually is the device. So it's using an ESP32, scanning every channel. So if you look at the numbers that you see are actually not broadcasting any signals, and the dots that you see is the amount of networks that are on that specific channel. So this is only like capturing the channels using Wi-Fi, but I can also like connect like a cellular connection to a a GPS SD card. So this is something that we made and also like open source. So it's like a PCB with tiny modules that you can replace, but this is like in a beta phase. So this is like a dormant project that we have going on. This is like the project that is working, so you can just solder it together if you have the components. Might take you a while to collect the components. One of my friends, Ian Tabor, Mintynet on Twitter, was kind enough to hand over some components. So the ESP32, like you saw, do connect a external antenna interface, but there are also ones that do not have an external antenna. And like for collecting all the data, you won't be able to collect as much access points as you would do with external antennas, but it would be more accurate as it would only show it like in the near vicinity. And he has some ESP32s that I can give away to people that want to start build this thing without an external antenna, and in return you have to do something for charity, like a charity of your choice. So I'm not going to test you. Going to just ask you to do a thing for humanity. So I have, if there's people that want to do that, I have some ESPs to start. So not the other components, but yeah, as a act of kindness of Mintynet. So kudos for Ian, whose car was stolen, and he's like world's best car hacker, in my opinion. For people that do not want to wait or like order on Tindy, we have some of the PCBs here. So if you want to, you can print them yourself. It's open source. There's Gerber files, but we have them here as well. Okay, that's basically what we have to say. So there's like a final slide with the contact details. So, oh, yeah. So this is Joseph and I. Yeah. Thank you.